So let us write the equations of motion in terms of Flaschka coordinates.
So we had the following Hamiltonian. Q minus QG plus something like that.
Yep.
And we have the following Flaschka coordinates. Aj is equal to half pi pj.
Minus, if I remember well. Yeah.
Yes. Half aj minus q
Mhm.
plus 1. Well, so the equation of motion we can find from the Hamiltonian equations, and in general coordinate it was the following thing.
Yes, but you need the first derivatives with respect to time. You see?
First derivative with respect to time.
Yes, yes.
What?
If you try to differentiate A, you will get here some first derivatives of P and Q.
So the first derivative of A, J, it will be something like 2 bj square j minus 1.
Yes, but how to get this?
Well, we just need to write this thing and just take the derivative. Let me try. So ddt of half p j.
Yes, minus with minus.
Yeah.
Yes, but how to calculate the first derivative of PG? So all will be simpler if you write down the equation of motion in terms of P and Q.
Okay.
Okay. You will know the derivatives of P and Q just by just describing the Hamiltonian vector field.
So the Hamiltonian.
Yeah.
This coordinate it will be
With the canonical coordinate P and Q. So what is P dot and Q dot? You see, you have written it in terms of just Q, but it is described by the second derivative. If you
also. So pi dot is will be just.
if you keep both types of variables, it is quite richer, yeah.
The definition.
Mm-hmm.
And if I put here a Hamiltonian, so this term will be 0,
Mm-hmm.
and we will have only this term, and we need to differentiate it, and we will get this minus e to the power qi minus qj plus 1, the same thing,
Yes.
and then plus e to the power qj minus 1
Mm-hmm.
minus qj or something like this.
Yes, that's right.
Now we can do the same thing for the q,
Yes.
which will be just
Mm-hmm.
something. and you can see that this doesn't depend on any p,
Mhm.
so it will be just like this pi.
Yep.
With the summation.
Without summation, just pi.
Okay.
Uh-huh.
So pi here is this qi. Minus half qi. So it will be like q double dot.
Okay.
So we got our A. Wait. Yeah, so we got our A, and now we need to find, later I think we can define it by B after we get the expression of B in terms of P and Q.
Try to find it, yeah.
So in that case, this Bj is it's just we want to find Bj dot. Just individuals. Not make mistake.
Okay.
Half, and then this half comes
Mm-hmm.
with derivatives of this qi, like this, right?
Qj.
Yes.
Mm-hmm.
And then the whole thing.
Mm-hmm.
We have also this one. So we
Mm-hmm.
need to write the derivative of this also
Yeah.
with a minus sign.
Yes. It's multiplication. What does it mean?
Multiplication.
No. It's just the difference.
Something like this, yes. That's what I wrote in.
Mm-hmm.
And so then this exponential.
Yes. Very good. Let's try to write
Simplify
it
somehow.
in a concise form.
So you can see that this thing is 2bi.
Mm-hmm. J.
Yes.
Mm-hmm.
And what is this? I can write directly. So 1 over. So pi
Mm-hmm. Pj.
is pj minus pj plus 1.
Exactly. Mm-hmm.
And yes, multiplied by, and we know that pj is actually aj, right? So maybe it's better to write like that. So that we have half pj, which is aj, minus aj plus 1 multiplied by
There is a minus here also.
then it will be just a plus.
Yes, we have to change signs.
So it will be plus and it will be minus, right?
Yeah.
multiplied by 2 bj's. So 2 and 2 will cancel out. So
Uh-huh. Very good.
So we got here. Yeah. Okay. So that one and
It's a bit bj dot. This one.
yeah.
Uh-huh. Okay. Very good. And
Maybe I
for
can just like
aj dot.
aj dot is here.
Uh-huh.
So let me write here. aj dot is minus. G plus 1.
Yes, but the first equation, how to extract, we need to express it in terms of a and b.
So this is nothing but just aj dot, right?
Mm,
Because we see that Q1 is Qi dot is just Pi.
Yeah.
So if I put here another dot, it will be like Pij, which is this. So I'm trying to say is that isn't it just this Pi double dot?
yes, but you know pj dot is equal to this.
Okay. Yeah, but I want to express. Yes, I want to express this thing in terms of A and B, isn't
Yeah.
it? Yes. So we got this thing. It means. Maybe I can find it exactly from here. So.
You have to express this in terms of a and b. This is pj dot.
And Pj dot.
And pj, aj is minus 1 over 2 pj. So they are just proportional.
Yeah. So that's then. Then Pj dot is just here 2.
Minus 2 aj.
Yes.
Uh-huh.
So it is. So you put it here. It will be like half. Not half, but just
No,
aj.
now you have to express this in terms of a and a and b. Okay?
Mm-hmm. So when you say we need to, so this is just this one, right?
Yeah.
Yeah, but we see that this is already we can write in terms of
Yeah.
A.
So it's principally the same.
Yeah. So that's it. So we already found it. What is this
Yes.
in terms of A and B, which is just only A depends on A.
aj dot.
Yes.
Uh-huh. And we have to express it in terms just of coordinates on your phase space, without derivatives. On the right,
Yeah, I understand.
we should have something just in terms of coordinates. You see, it is very close.
This one is
and
very
this.
close to that
Yes,
one.
but we have 1 over 2
1
here.
half over. Yes.
What to do?
So there we need to take 2 times.
It is closer to bj square,
Yes.
Okay.
Yes.
but there is some coefficient.
Yeah, the coefficient should be 2.
I would say 4.
4, yes, 4. So 4bj square plus,
And minus. Because of this.
Yes, there is already minus.
Uh-huh. And plus. The same, but for the different values of indices. Very good. So it's a description, but could you now write down the equation on AG? AJ dot.
So we got pi dot is equal to this.
Yeah.
And then pi dot is this. So it means like aj dot is just two j square minus 2 j minus 1 square.
Yes, it is very similar to what we need. Bj. Yes, yes, yes. No, it's correct. It's correct. Okay.
So that's it.
That's it. Thank you very much. Let us calculate the Poisson bracket in terms of the Flaschka coordinates. I suppose we need only the definition of Flaschka coordinates and the canonical Poisson bracket, but you know them.
So we need this one, right?
Mm-hmm. No, it is more simple. Just the Poisson bracket between A and B. Do you agree that the Poisson bracket between A and A are trivial?
Or it's just delta percent.
Sorry?
Delta percent between coordinates, right?
Between A and B?
Oh,
No.
between A and B.
Between P and Q it is canonical. But now we have to calculate Poisson bracket in new coordinates in A and B. Sorry? Yes, but there is a sum.
Yes.
There is a sum.
And
Mhm.
second part.
Yeah.
What I mean is the second part is zero because with gravitational just B is not B.
Aha.
B is
Yes,
zero.
yes, you're right. Yes. Very good. I'd like to write here the summation over K. Okay. It is mainly the first point to choose which K are suitable, which values of K. I don't understand. You see, here A is with the index I, B is with the index J.
Well,
First of all, I propose to think about the values of the index k, for which indices k this product is not zero.
well, for
There is quite strong restriction.
well, it's just only two components of.
For the most of indices I and j, there are no non-trivial terms.
Yes.
There is a non-trivial term if j is equal I, and with if j is equal I minus 1. For all other choices, it is trivial. How to understand it strictly? So you see, you differentiate AI with pk,
It should be delta Kronecker simply.
and k should be
Always.
only I. Okay? So in this summation, non-trivial term here is only if k is equal I.
Right.
And here, this term is non-trivial if k is equal j, or if k is equal j minus 1. No, if k is equal j plus 1.
Yes, this one.
Aha.
And I have already written with the substitution. Yodor has so plus it this term.
But
Just k.
they should be somewhere the Kronecker symbol with j.
I will have already substituted because there should
No,
be
no, the right side doesn't depend on j. It should depend on j. Do you agree?
mean,
In this form, the right side doesn't depend on j.
what I mean is there should be with right something like that and Kronecker symbol Yodor right?
No, it's not right.
Well,
I think
so
that
it's-
this term is
okay.
with kj. Maybe not. Maybe k.
well, but it's the same, no? I can write like this and Kronecker symbol just move to the outer brackets.
It couldn't be correct because both sides are non-trivial if j is equal to k, or j is equal to I. But this bracket is not trivial else if j is equal I minus 1. It means that somewhere it should be the Kronecker symbol j k minus 1. Or
It's already done by the fact I moved not the k but the yod component. Well, I can write. like this,
so
but
you see, AI and BI it is not trivial,
Yes.
and AI BI minus 1 is non-trivial.
Yes, yes.
In your formula, it is you mean here k plus 1?
Yeah.
It's better, yeah.
I mean, this means this term.
It is not the same. So you see, it is non-trivial in two cases.
Yeah, I understand
So it
why.
means that somewhere it should be delta I j and delta I j j plus 1. Somewhere.
indices and it will be right.
It's the end.
Yes.
IJ.
And they should be down, right?
You see, both
Both sides.
are not trivial.
Yes,
They should be two Kronecker functions. If not, it's not correct. Okay, let me compare with my calculations. Yes, there are some mistakes because here you have 1 over 2. 1 over 2 in B.
because
Yes, but you have to keep here else 1 over 2. And here you have delta J over 2 B I minus 1. Is it right?
yes.
You see here else 1 over 2 and 1 over 2, and it means that when you differentiate you get here 1 over 8 and here else. It means that you get here such a function AI bj, this one and minus delta and minus delta
Plus 1.
I J plus 1 over 4
BU.
BI.
And now we introduce like separators, right?
Just a moment. If you get this expression, it's I agree, but you see it's a little bit more simple just to write non-trivial brackets. It means that you say that non-trivial brackets exist only between such coordinates AI and BI with the same indices, or with AI and BI minus 1. Okay, and in this case it is this case or not? No. In my case, in my calculation, it is like this. BI, and in this case, it is 1 over 4 BI minus 1. Let's compare. So, first of all, I propose to you to describe the Poisson bracket just to say which brackets are non-trivial. Up to my opinion, it is simpler and more instructive. So my statement is all non-trivial brackets are such brackets. You have a little bit different answer. So let us compare them.
I don't see the mistake. Diagrams to up to the shape, it's
So in your case, A I B I is equal
this one.
No. It's my case, but in your case, it is bi minus 1. 1 over 4 bi minus 1. Yes, it's bi minus 1. Let us verify. Let us just calculate such Poisson brackets. AI is minus 1 over 2 pi. Sorry?
I've already substituted the indices. I'm calculating this part and this one. I'm already taking the Kronecker.
Could you calculate just this Poisson bracket?
With the right indices or whatever indices?
As you like. And here there is minus 1 over 2. Yes. Bi. Bi. So this one, and not this one.
Yes.
So there is a mistake in your formula, but so very close to the correct one. Could you find the arguments the only non-trivial brackets are of this type? Sometimes it is simpler to understand which Poisson bracket to calculate. Because when we calculate Poisson bracket, we look when the expression on the left and on the right have the same indices of P and Q, because only such indices appears in the Poisson bivector, in the standard Poisson bivector. Okay. And if we choose the Pj here, we have to choose only Bj or Bj minus 1 to get Qj here. So it is, in a sense, evident when you look. But you can get it from your calculation. But you see, it is quite delicate. In your calculation, there is a mistake. Just a moment. So now it's a home task from today's lecture. Yes, to describe the Poisson structure in terms of Flaschka coordinate, and we get it. And you started to talk about the Lux representation.
Yes, from the column block.
Yeah. I also thought it was like homework for today's class.
Uh-huh. So, but is it clear for this calculation?
Yes.
The principal thing is sometimes it is more useful to just to pick up the good coordinates with non-trivial Poisson bracket and to express them. Let's now discuss the Lux representation question. What was the problem and how you solve it?
And we have done with the Poisson brackets from the classical type.
Could you repeat the task about the Lux representation? What was the problem?
The problem was we have Flaschka representation.
Flaschka coordinates.
And we have Lux operators.
Uh-huh.
Well, I have mixed A and B.
A on the diagonal and B.
Written like this.
Uh-huh.
So it should be like A1, B1.
Mm-hmm.
Here, B3, like that. And M is equals to 0 and
Yeah. Yes. And what was the question? How you understand the question? What was the question?
Oh,
Demonstrate this equation in Flaschka coordinate.
Yes, but which equation?
Which equation?
Yes.
Is the standard equation L точка. Yeah.
Uh-huh. Yes. Very good. Could you do it?
zero comes from so let's find the bell first, and it should be from what the structure is. Zero comes from now we can see from the matrices.
Non-zero K is on N.
Place, yes.
N. Which is N? The dimension.
So
Uh-huh. Uh-huh. Mm-hmm. Yes, very good. No, it's B. Uh-huh. Yes, yes, very good. Mhm.
And then we brackets use this one, which is it's pretty much the same, but it will give it's big. Which is should be equal.
Yeah. Yes, this is correct. Yeah. Mhm. And how to see this?
It's pretty much the same. We
Uh-huh.
I can read it.
Yes, please. No, I'm sorry, it's a little bit strange here. No, you get the I here.
I plus one.
Yes, I plus one I. As a product, you get some I element.
Again.
I think it's more natural to consider MII, LI plus 1, but which is 0 because M has only has no non-trivial element on the diagonal, so it's MI plus 1, LI plus 1, I plus 1. So this element is not trivial.
Which is fully.
But you have here I plus 1. This element is also 0. It has not such elements. So maybe you should place here minus.
I mean, I have just.
So it's not absolutely correct, but the technology is good. So that's right that you can control the element near the diagonal in this calculation. Okay, thank you very much. The method is very good, but there are some technical mistakes in the calculation. Thank you. Okay, I have one question for you about the Poisson bracket, which we have calculated in Flaschka coordinates. So I would remind them to you. So we have the following brackets: A, I with AJ is equal 0, BI with BJ is equal 0. Is it clear?
Yes.
Yes, because they both they have dependence only on P in P commute in evolution. B depend only on Q and all Q's commute. But we have non-trivial Poisson brackets. AI BI is equal minus 1 over 4 BI, and AI BI minus 1 is 1 over 4 BI minus 1. Does it remind to you something? Some Poisson bracket, some Lie commutator. Is it familiar to you in some sense? It could be. In fact, it's some reason why we organize these coordinates in the Lax operator form. So the Poisson bracket are very close to the Lie bracket on GLN. You see, just if we compare with the Lax operator of GLN, then this operator commute with this. Near this commutator relation up to some constant. So up to some constant, this operator is this 3 diagonal part of the general GLN Lax operator. But now the rest 10 minutes I propose to you to make exercises for the next homework to prove the formula that trace 1 A1 B2 P is equal BA. Let us start the calculation just to try to understand the mechanics. Would you like?
I'm not sure if we'll be able to do it in 10 minutes.
We will help you, and the important thing to start to understand all the notations and
Yes,
so A and B are just some matrices. Let us write them in tensor representation as the sum of some matrix elements multiplied by some coefficients. It is the first step to. Yeah, very good, very good. And the same for B. B with B.
You can also write this elements A1.
Yeah.
Which is just the same thing with tensor multiplication.
Yep, perfect.
And B2. These are also you can maybe write P also by here. If it's possible. P is just the sum of EIJ times
Yeah.
So now let's write left hand side.
Mm-hmm.
Maybe we can first try to calculate this and then take the trace.
As you like. Yes.
One is ij. This
Mm-hmm.
multiplied by b2. Maybe you can
KL. Very good.
and then b.
It is possibly good. Yeah, yes, very good. Mm. Mhm. What is important now that these are numbers and these also. So we can put it on to the right, to the left, as you like.
This one?
Yes, these are just coefficients.
Yeah, let's start.
Non-trivial multiplication acts only on matrix units.
So we have sum over I, J, K, L, R, S.
Mm-hmm.
Then E, I, J. Answer, yes, directly to that.
Yes, we can directly multiply this by this. No, before tensor multiplication.
Yes.
Because it's also in the first component.
Yes, and then
Here is 1, so on the second component we have this and this.
yes.
Mm-hmm. And then we multiply it by coefficients, by scalars.
Yes, so
A,
we have J, we have B,
KL.
KL.
Yeah.
That's it. Okay, we can rewrite with some, get rid of some indices over here.
Yes, we know how to multiply matrices.
Yes.
You say we need here the delta function. No, it is IS. So we need these indices coincide, IS, and delta function of this.
Times e to the power e
The same, K.
Delta L is
Perfect.
something like this, and multiplied by this.
Just coefficients, yes.
Okay, now
So maybe it's a good place to take trace.
yes. So
And the trace
then
over
we'll have another formula for that.
on the first components. So
Yes.
it's important. The trace over the first component.
Yes.
Mhm.
Here.
So it considers only this part.
Yes, and there is a formula for trace also that we know. Trace 1 of EIJ times EKL is equal to delta IJ
Mm-hmm.
EKL.
Exactly.
Now we can use it here.
Mm-hmm.
It will give me this delta IS,
Mm-hmm.
delta JR, this delta also over here,
Yes.
delta LS, and that's it. Then this one here because we didn't act over that,
Uh-huh.
and the left.
Perfect. There is a summation, but we suppose.
Yes. So this we can write now. We can get rid of some other delta, conjugate delta. So if we think that all are the same, I mean 1, then it will be just these 3 things, but with different indices maybe.
So maybe in this step it's better to keep the indices. So here there is the sum of 6 indices, and here you identify some subset of indices.
I, J, K, R,
L, S.
R, S. Sorry.
K, L, R, S. And we have this identification. So I is equal S, L is equal S, and J is equal R.
Yes.
Could you write it? So it means that you have now only 3 index, three indices.
Equal to S.
And equal
J
to and equal to L, also to L.
Yeah, equal to L.
And J equal to R.
And J equal to R. And then we can use it over here and get rid of that. So E.
Could you write the sum over 3 indices?
So let's keep it here. E.
E, J, and what else? I suppose K.
Yeah, so it's my choice which index I want to take. So let me take just I and J.
Yes,
So
but there is also the index K.
Okay.
So the sum is over 3 indices. And then we have to rewrite doing all necessary identifications.
Yeah, so what is K? K is K. What is R? R is J. I and J keeps P, K. L is I.
What do you think?
This is just, this have to be BA.
Are you sure?
Well, if I'm not sure, we have things to calculate and check. But I think I'm not sure, like it's not obvious to me.
You have to remind the definition of the product of matrices.
Wait, yes.
BA IJ is just BIK AKJ.
Yes.
Is it the same? So here the indices are a little bit different.
If you write it over here, yes. So
Okay.
if you write it here,
Yeah.
I understand it. Yes. So this is now BA.
You see, in this calculation, we suppose that the coefficients are commutative. So we can do this inversion.
Yes.
So, but it makes sense in non-commutative case also because it is very useful even for quantum integrable systems. So it's good to remark here that the statement is true if the matrices have commutative elements.
So A1, B1 are commutative.
Yes. The coefficients here, the coefficient they commute between themselves, A and B. Thank you very much. Very good. You understand well the technique. We will do more interesting examples next time, and we stop for today.